welcome to today's class. Today's class, we'll be looking at engineering maths, and we'll be talking about the function of several variables, functions of several variables. But before we go to function of several variables, I want to take you back to your maths in year one. That was the function of a single variable. So going back, we know that, let's say y is equals to f of what? X. Now we are simply saying that y is a function of f of x, where y is the what? Dependent variable and x is the what? Independent what? Variable. Also, we can also say that x is our what? Input what? Variable. That means for every input of x, we'll get a corresponding output, right? So for every input of x into the function, we'll get a y value. So now, this can be seen as what? Function of a what? Single variable. A single variable, because x is the only variable there inside the function. So it's the function of a single what? Variable. For example, let's say y equals to what? 5x minus what? 2. Let's say y equals to 5x minus 2. Now let's say we take x as a real number or a positive number. Any value we put in x, there will be only one y value. Y will not have two values. If we input 1 into x, if we take x as 1, now we take x as 1 now, for instance, the corresponding output will be what? Anywhere we see x, we put in 1, so that will be what? 5 what? Into 1 minus what? 2, which will give us what? 5 times 1 minus 2, 3. So this is the logic behind function of a single variable. A variable means an unknown, right? Something that you don't know the value of. So anytime you see a value, whether x, whether a, whether b, as far as an alphabet, not a number, then it's an unknown. It can be called a what? Variable. So now moving forward, let's look at functions of several variables. Function of what? several variables. Now, let's say we are given a function z of what? X, comma, y. Let's say we are given this. Now, we know that z, which is the output, is a function of x and y. So, for us to get the value of z, we must have two different variables. One variable will be for x, and the other will be for what? Y. Then we can get the value of x. Now, let's say, for example, we have a rectangular box and we have the length and the breadth, right? Now, we are asked to find the area of this geometry, that's this shape, this rectangle. What is the area of a rectangle, please? Anybody? Length times breadth, right? Correct. So now, we know that area A is equal to what? Length what? Times breadth, right? So we can say that area, which is the output, right? Area, which is the output A, is a function of what? The length, comma, and the breadth of this rectangle. Do you grab? That's what function of several variables mean. But this now is simply telling us that A is a function of L and B. So we put the value for L. If we had a value for L, let's say L was equal to what? 10 meters, or let's just put 10, and 10 meters, and this was equal to what? 3 meters. So now we know that L is equal to 10 and B equals to 3. So if we want to get the function, we will now have that area A will be equal to what? L, which is 10, times B, which is 3. So our area will what? 30, right? So that's what it means by what? Function of two variables. So now this is a function of two variables. Why this is a function of just one variable. Now we can have functions of several variables, up to 3 and so on. Now let's take an example for a function of 3 variables. Let's say we had W the function of, now let's say this now is a 3-dimensional shape, right? So let's say this is a 3-dimensional shape and we're asked to find the volume. So what is the formula for volume? Say what? Okay, let's say this is the length, this is the breadth, then this side, this place from here to here is the width. So our volume will be what? So let's not use W since you're using W. Then breadth, let's just say this is the breadth, and let's just say this is the height. So we can say our volume will be the what? Length times what? Breadth times what? Height. Breadth is still the same thing as width. I'm sure you are aware of that. Yes. So we say the volume is equal to what? Length times breadth times height. And we have the function of what? Let's just say x, y, z, right? So this is a function of three variables. But we want to put it in this form. We have that v is a function of the length, comma, the breadth, comma, and the height, right? So now this height, let's say the height is what? This breadth is what? 4 meters. So if we input our values to look for b, we have that v will be equals to 10, that's L, 10 times breadth, which is 4, times height, which is 3, which will give us what? 120. And we can call this a function of what? 3 variables. So we can call this a function of 3 variables. Okay. So I hope you have taken down. Are you taking notes? So let's proceed now. Let's look at what they call domain and range. How to know the domain of a function and how to look at the what? Range of a function. Do you know how to look for the domain of a function? Let's look at that now. So for the domain, and what? Range of a function. Now take note. Definition. Take note, please. Hope you're writing. Domain. Domain. A domain can be defined as an ordered set of variables, of input variables, an ordered set of input variables that will give or produce a unique set of real numbers as that will produce a unique set of real number. Let's not remove the set. That will produce a unique real number as the dependent variable. That will produce a unique real number as the what? Dependent variable. Did you get it? Did you grab? Did you get it? You can also say or, right? Or the second definition. The domain can be defined as the set and other set of variables that will determine whether a function is what? Defined. An ordered set of variables that will determine whether a function is what? Defined. So I'll explain that with examples. Now, if you are done, let's take the definition of range. Range can be defined as the set of what? Output what? Variables. That's all. As simple as that. The output variable is the range, while the input that will give or make the set, the what they call function defined, is what? Domain. So let's take an example. If we're given a polynomial function, let's say we're given a polynomial function. You know what the polynomial is, right? So let's say we are given a polynomial function x squared plus y squared. This is a function of two variables, x and y, right? Now, to determine this now, that's the domain of this function, of this polynomial function. Take note, first of all, this function has no what? Restriction. It has no what? Restriction. So, any value we put in to the function, any value we put into the function. Now let's say, okay, this is going to give us z, right? So any value we put into the function, we will still carry. If we put 1 here and 1 here, let x be 1, let y be 1. The function will still be what? Determined. Let's take an example. Now let us say, let what? X be 1, and let's say let y be 1. So if we put x as 1 and y as 1, we have that 1 square plus 1 square equals to what? 1 plus what? 1, which is equals to what? 2. So as long as when we input our input variables and our output will not give us 0, that means that function is what? Defined, right? But if we put values that, good morning, that will not give us, that will give us 0, that means this function is not defined. So now we can say that, let me clean this part. We can say that our range R is a set of what? S, comma, y Are you looking? Our range is a set of x, comma, y such that x, comma, y is a set of all real numbers in two dimensions. Do you understand what I just wrote now? I should recap. All right. Now, since we know that as long as we input a real number as variables in x and y, anyone, since there's no limit, this now there's no limit. As long as we put any of the real numbers, 1, 200, and infinity, till infinity, into x and y variable, we'll always get the function to be what? Defined. So our range of values that can go in as x and y will be all the what? Will be x and y such that x and y is a set of what? A subset of what? The all real numbers. So now x and y is a subset of all real numbers. So any value you put in as x and y, it will be a set of what? All real numbers. You know what subset and superset means, right? Superset is like the global set. Let's say all year 2 students in Faculty of Engineering. Let's say that's the main set, right? So a subset is all the civil engineering year 2 students, right? Or all the Kempet year 2 students. Now, if for instance now there was to be, let me say, an event, and they said the event for x and y now, let's say Kempet to be x, mechanical will be y, and they say mechanical, or they say any, let's not say mechanical and Kempet, they say any of the engineering students can come, right? And let us say marine decided to come, civil decided to come. This thing, marine and civil, is still inside the what? Global one, right? It's still inside the general engineering body, right? So we are trying to say that any number you put in as a value of x, or any number you put in as a value of y, it will surely give you what? A defined polynomial function. This is the polynomial function. Let me write it down. A defined what? Polynomial what? Function. So this is our what? This is our range. Now we look at other examples. We'll look at an example of a logarithmic function. You know what a logarithmic function looks like, right? Okay. We'll also look at examples from a rational function. We'll look at examples from a square root function. So now, let's clean the board so we can proceed. So when we look at other examples, you grab the concept of what I'm saying, right? Let's just proceed to the other examples. So, example number 2. Will be find the what? Find the what? Domain and what? Range of the what? Following functions. So let's take the first example. We'll take 3 examples. I'm writing this going down, okay? The first one, let me confirm, let me not make a mistake from the example. Okay. Let's say f of what? X, comma, y equals what? In in y minus what? 2 what? X. S comma y equals ln y. Okay. This is example 2 now. Yes. F of xy all right, you can take note, take this down. We'll also look at the next example. Here's that example. F of x comma y equals 1 over x minus what? Y square. 1 over x minus what? 1 square. And we'll look at the third example. Look at the third example. Example 3. We say f of x comma y is equals to what? The square root of the square root of 4 minus x square minus what? Y square equals 4 minus x square minus what? Y square. So let's look at these 3 examples. So you have an idea of how to find the domain and range of a what? Function. All right. So we are given these 3 examples to find the domain and range of the function. So for the first one, we have that f of x comma y is equal to the natural log of what? Y minus 2x. You know what that sign means, right, Ellen? Lynn? That's natural log. Now, have you finished writing? You're done writing? All right, so let's proceed. Now, take note. For us to determine the domain of this logarithmic function, this is a logarithmic function. We know that the value should be what? The value, that's this expression, y minus 2x, should be what? Greater than what? 0. For this function to what? Be defined, right? I don't know why I'm not always closing my bracket. Let me close it. Please close your own. For us to determine the function, to know if it's defined, the domain simply says the set of what? Ordered other set of numbers or other set of variables that would make sure the function is what? Defined. For us to get the what? Domain, to make sure that this function is defined, we need to know that this expression should be at least greater than what? 0. So let's say, for instance, we have in P. So this should be what? Greater than what? 0, right? So we can say in that same sense that in, no, not in, sorry. The expression y minus 2x should be what? Also greater than what? 0. So if we transpose this, transposing like taking minus 2x to the right hand side, we'll have that what? Y equals to what? Not equals to, sorry. Greater than what? 2x. Now, if you see this thing now, this one, they're telling us that this is restricted. Why this one now? There's no limit. You can put any number for y and x. But this one, they're telling you that any value you put for y, it should be greater than 2 times x. And any value you put for x, if you multiply the value by 2, y should still be greater than it. So there's a limit to our what? Our domain, right? Now, for instance, okay, we'll do that when we're looking for the range. So now, we can simply say that our domain will be what? Set of what? A set of what? S, comma, y variables such that y is what? Greater than what? 2 what? X. Very simple, right? So this is our domain. This thing, this symbol you see here now, it's called a vertical slash. It's called. No, listen, see. Come on, let me put my phone on. Listen. It's called a vertical slash. Vertical slash or line. Let's call vertical line. It can also be written as this. That's column. Right? You can interchange any of them. Either you use this or you use this. If you see this in your textbook or you see this thing in your textbook, know that they are the same thing, right? Such that it's trying to explain this. So do you understand what I just said here now? So let's proceed to finding the what? The range. We found the domain, right? And this is our restriction, that any value we choose for x, if you multiply it by 2, it should be greater than y. So now let's move forward to find our range. Moving forward, if we bring out this condition, y equals to 2x, now let's say let's take x as equals to 1, right? So if we input x as 1 there, it will be what? 2 times 1, right? Which is what? 2, right? So the condition says y should be greater than 2 times x, right? And if we take x as 1 and we times it, we get 2. Therefore, our y should be equal to what? 3. I seen it. Our y should be equal to what? 3. Now, I should recap. Okay. Now, this is the condition for choosing the variable that we'll put in our function to know if it's defined, if it exists, right? Now, for us to do that, our domain is giving us a hint that any number we are choosing, we should observe this condition. And now we are observing this condition. We are using trial now. We are doing the first trial. Let's say x is equals to 1, right? We cannot say y is equals to 2 or y is equals to 1. If we say y is equals to 1 and we do 2 times 1 as x equals to 1, now we put x here and we get 2 times 1 and the value is 2. If we choose y as 1, it will now be 1 is what? This is wrong now, right? Even though we do 2, this is also wrong, right? But if we do 3, this is correct, right? Why these 2, they are wrong? So we have to choose our y value as 3 for it to meet this restriction, this condition. Do you understand? All right, let's proceed. So we have x as 1 and y as 3. So we can say that this function will now be y minus 2x we know that y is equals to 3, right? So if we input the value for y, we'll have what? 3 minus 2 times the value for x, 1, right? So we'll have what? 3 what? Minus 2 times 1, 2, right? So we'll have our value as what? Equals to what? 3 minus 2, 1. So the function what? Is what? Defined. As far as we do not land in what? 0 is what? Defined, right? So the function what? Exists. So now, we can now say that our range will be where will I write? So let me clean this part. We can say our range will be equals to what? All numbers from what? Negative infinity to what? Positive what? Infinity. All numbers from what? Negative infinity down to what? Positive what? Infinity. So now, we've gotten our domain as a set of x comma y such that y is what? Less than what? 2x. And we've gotten our range as all real numbers from negative infinity to all numbers from negative infinity to what? Positive infinity. So now let's look at the next example. Now, example 2. Let's look at example 2, the solution. So for example 2, we have what? F of what? X comma y is equals to what? 1 over what? X minus y squared. Please, did you follow this first one I just solved? Did you follow? Did you understand? You understood it, right? Okay, let's proceed. So for this one, we have that, you know, this is a polynomial. No, this is a what? This is not a polynomial. I mentioned it earlier. This is a rational function. A rational function. Take note. This is a what? Rational function. And for a rational function, our denominator must not be what? Equals to what? 0. If not, our function will be what? Undefined, right? If it's equals to 0, our function will be what? Undefined. And we want to make sure our function is what? Defined. So now, for us to make sure our function is defined and get our what? Domain and range, we are going to do what? Take this expression x minus y square. This is the expression, right? So if we transpose this, we have that what? X is equals to what? Y square. We have that what? X is equals to what? Y square. And if we have that x is equals to y square, they're telling us that anything we are doing, or any value we choose for x and any value we choose for y, we should make sure that it's not going to be 0. Therefore, if we say x is equals to y square, we should make sure that any value we choose for x should not be equals to what? The y square. So we'll put this sign. This sign now means not equals to, right? And also, x minus 2 minus y square should not be what? Equals to what? 0. So now, since we've gotten this now, this condition or this limitation, we can now simply write our what? Domain. So our domain will look like this. Our domain will look like this. So the domain D will be set of what? S comma y such that what? Oh, that person is in the spirit. S is not equals to what? Y square. That person is in the spirit. Yes, yes, yes. Correct. That means you're flowing. You're following in the spirit. So this is the first one. Or you can say that the domain is such that it's a set of what? S comma y. Let's use this symbol this time. Such that x minus y square is not equal to what? 0. X minus what? Y square what? Is not equals to what? 0. So we've gotten our domain. Now, to get our range for this example is kind of tricky. So please write. I'll give you like some seconds to write so you pay attention when I'm explaining this other part. Are you done writing? If you're done writing, let me know. Okay, let's just give others like 30 seconds. Now, we have this function, right? F of what? Xy is equals to 1 over what? X minus what? Y square. This f of xy, we can replace it as the output because this f of xy, now you see the output, right? So we can say f of xy is the same thing as what? Z, right? All right. So now, since they've told us that we should make sure that any value we put here, if we put 1, we do 1 square. 1 square will be what? 1, right? So we should make sure that x is not equal to 1 too. Because if we do 1 minus 1, it will be what? 0. And once you do 1 minus 1, 0, our function does not what? Exist. But we want our function to exist, so we cannot choose 1 for x and 1 for y. So if we choose 1 for y, the value for x should change, right? It can be maybe higher, like 2. Now let's just do it this way. Let's say, let y be equals to what? 1, right? So if we put y as 1 in this rational function, anywhere we see y, we put 1, we'll have that z will be equals to what? 1 all over x minus what? 1 square, which will give us what? 1 all over x minus what? 1. Thank you very much. So this is our new value for what? Z, where y is equals to 1. Let me clean the board so we'll proceed. All right. Moving forward, we now have that z is equals to what? Please call it for me. 1 over what? X minus 1. Now, we don't want to put x as 1 too, right? So my phone is here playing another thing. My data is on. We don't want to put x as 1 too, right? Because if we put x as 1, it will be 1 minus 1, which is 0. And the denominator cannot be what? 0 for a rational function. So what do? Let's make x the subject of the formula. What do you think? So if we make x the subject of the formula, mathematicians in the house, what will the new equation look like? Or what should we do first? We cross multiply, right? And if we cross multiply, we'll have that what? Z into what? X minus 1 is equals to 1, right? So next, we are making x the subject of the formula, right? We divide both sides by what? By what? By z. Dividing both sides by z, this will cancel out this. So we'll be left with what? X minus 1 is equals to what? 1 over what? Z. Moving on, what do? We take out minus 1, right? To the right hand side. So we now have what? X is equals to what? 1 over Z plus what? 1. So now, we can say when y is equals to 1, x will now be equals to what? 1 over z plus 1, right? So we can now write 1 over z plus 1, comma 1, right? 1 over z plus 1, comma 1. That's what will represent our value for what? X and what? Y. Now, moving on, we want to find out what exact value are we going to put here. What are the exact values we are going to put here now that will give us the function to be what? To be defined. We need to find out that thing now. Moving on, let's use a line graph. Now, this is what? 0, right? Let's say this is positive what? Infinity. And this is what? Negative infinity, right? Since we cannot put z as 0, You know, z is the output function, and we don't want the output to be zero, right? Since we cannot put z as zero, you know what an output function is, right? Like when we put in the values in the polynomial like this now, like this polynomial now, right? We put in the value. We don't want our output function to be zero, because if it's zero, it's not defined. So since we don't want z to be zero, this will now be an open interval. This will be an what? Open what? Interval. So now our domain will be what? D is equals to what? The set of what? All, that's the all negative what? Infinity, comma, to zero, union what? Zero to what? The what? Positive what? Infinity. So this is what our domain will look like. So once we get our domain to be from all negative infinity to zero, because this is an open interval, we don't want zero to be part of it, union zero to what? All positive what? Infinity. All right. So the third example, we have cleaned the board for the third example. Okay, let me check. The third example, that was a square root function, right? So I've already given you the domain for this, right? This is the domain. So this should be our range. Thank you for asking that question. This should be our range. I've given you the domain now. This is the domain. This is our domain. So this is our range. Sorry. This is our range. Now the third question says square root of, should I clean here? Should I start from here back? The third question says please, can someone call the third question for me? Okay. Say what? Square root of what? All right. So this is the third question. Take note. This is a what? It's called a square root function. Or a squared function. Now, for a squared function, the rule is we should make sure that what is inside here will not be what? Negative. It should not be a negative number. It can be zero or greater than zero, but it should not be what? Negative. Because if you enter negative, you enter what? Complex numbers, right? So now, using that knowledge, we have that. Are you done writing here? We have that. Is the mic on? Is it green? Is it showing green? It's not showing green. Jesus. People are pranking me. Can you imagine? Okay, is it recording? I beg, that prank is too expensive. Ah, I nearly cried though. Okay. Sorry. So let's proceed. So we have that since the expression should not be negative, we now have that 4 minus x squared minus y squared should be what? Greater than or equals to what? 0. We said it can be equals to 0 or it can be greater than 0, but it should not be what? Negative. That means if it's less than 0, moving from the line graph, that means you're moving towards the negative direction, right? That's why we have this condition. So this is another restriction. So now working with this restriction, we can now get our what? Our domain, right? So our domain, first of all, let's transpose this to this other side. We now have what? 4 is what? Less than. Okay, greater than. It's going to change, right? It's true. So it will now be greater than. Greater than, less than. It's greater than now. This is correct now. Why are you now confusing me? This will now change to what? Positive x squared. This will change to what? Positive what? Y squared, right? So now let's rewrite this. X squared plus what? Y squared. Now this sign will change. It will now be what? Less than what? 4. So now our range, our domain, sorry, will be what? Set of what? X comma y such that x squared plus y squared should be what? Less than or equals to what? 4. So please, why I touch different type of function, so you know the conditions, right? We've worked on polynomial function without restriction, right? We've worked on rational function where we say that the denominator must not be equals to what? 0. If it's not equals to 0, that means it must be what? Greater than what? 0. Next, we looked at the what? Which function did we now look at? Okay, we looked at the logarithmic function where we say that the log of the expression should be what? Should be what? Should be greater than what? 0. Should be greater than what? 0. Sorry, the first one I said now, listen very well. Don't confuse me or don't confuse yourself. Logarithmic function, the condition should be greater than 0. For the rational function, should not be equals to 0, not greater than. Should not be equals to what? 0. So from there, you can get your what? Domain. And once you've gotten your condition for the domain, then you now know how your what? Range is going to look like, right? So now, we've gotten our condition for what? Our domain. So now we can proceed to our what? Range. Moving on to our range, we can say that this function so now let's get the least value of z. Since you are looking at the range, we are talking at the values that we can accommodate. So now let's first of all, let's get the least value of what? Z. So now the least value of z then we also get, after the least value of z, we get the what? Highest what? Value of what? Z. Now, for the least value of z, we say that for a squared function or a square root function, it can be 0 or what? Higher than 0. That means the starting will be what? 0. And 0 is the smallest number, right? So the least value of z will be what? 0. All right. Now, take note. For the highest value of z, observe. For the highest value of z, we need to take a number that if we input it in x and y, it's not going to reduce this constant number here. It's not going to reduce it because we need this value to be very high. You get? We have 4 here, right? So if we take, let's say, we take 1 here, 1 here. 1 square will give us what? 1, right? 1 square will give us 1. Minus 1 minus 1 will be what? Minus 2. 4 minus 2, the value has reduced. It will now be 2, right? And we don't want that. We want it that the value should be high. Let it be high so we can get the highest value. So if we take 2, the same thing. 2 square will give us what? 4, right? 2 square will give us what? 4. Minus 4 minus 4, minus 8. Minus 8 minus 4 plus 4 is what? Minus 4. The value has what? Also reduced. We don't want that. So now, we will now be thinking, which value are we going to put in to maintain this 4 so it's not drop? So the value we are going to put in, definitely, it should be as low as possible. If we try 0 now, if we put in 0 here, we'll have that, let's say, x and y, we put in 0, right? We'll now have that z, for the highest value, be what? Square root of 4 minus 0 square minus what? 0 what? Square. So we have that z is equal to square root of what? 4. 0 square will be what? 0. 0 square will be what? 0. So we have that z is equal to what? The square root of what? 4 minus 0 give us what? 4. And z equals to square root of 4 is what? 2. So we have that our highest value of z will be what? 2. So this is going to be our highest value of what? Z. Knowing that, we will say that our range will be from what? 0 to what? To 2. Are you seeing it? That will be our range from 0 to 2. That will be the least value of what? Now the least value of z, we're doing try and error for our values of x and y. We tried 1. We're making sure now to check yourself. We check that anything we put here, by the time we simplify, it should not affect this constant. It should not reduce the constant because we're looking for the highest value, right? So, okay, the least value. Now the least value, we say that from our domain, the condition was like this can be 0 or what? Higher than 0. So we already know that it's going to start from 0, right? So we now say the least value is what? 0. That's how we got the least value. Then the highest value, this is how we got the what? Highest value as 2. So next up, let's look at another topic. Let's look at another topic. Let's look at another topic. So this topic, we have covered domain and range. Please change this bracket to a square bracket. Change it to a square bracket. This other bracket means another thing. Change it to a square bracket. Change it to a square bracket. Okay. All right, so let's continue from where we stopped. We'll be looking at another subtopic or another topic. Okay, we're looking at limits. Limits. Have you heard of limits before? You guys did calculus last semester, right? You did calculus now. Second semester you won, right? And if I can recall, it said the limit of a single variable, let's say lim of f of x as x approaches a given number a is equals to what? L. Am I right? We say that the limit of a given function f of x as x approaches a is equals to what? L. That was for what? A what? Single what? Variable, right? Also, we are now asked to check if the limit exists, right? And to do that, let me recap for those that are just entering. I said from our calculus in year 1, second semester, we know that for a single variable, that the limit of a function f of x as x approaches a is equal to a given number called L, right? And now, if we are to check if this limit, the limit of this function exists, we'll do what? We'll take the limit of the function x as x is approaching a from the negative direction. You know, it can go towards a either from the negative or from the positive, right? And if it's going from the negative direction, that it will be equal to what? L1, right? Then we can also say that if we take the limit of the function f of x as it's approaching from the what? Positive direction, right? Is equals to what? L what? 2. Are you following? Now, if we are to check if this limit exists, we have to say that L of 1 should be equal to what? L of 2, right? For it to what? Exist, am I right? When we check for L of 1, that's the function from the left-hand side as x is approaching -1. That's the left-hand side of the graph. If we check the limit and we get a value, and we check it from this other side and we get a value, we will now say that L of 1 is equal to L of 2. If L of 1 is equal to L of 2, that means the function what? Exists. For it to exist. But if L of 1 is not equal to what? L of 2, the function does not what? Does not what? Exist. That's for what? A single what? Variable. But now, We are moving towards what? Functions of multiple variables. So now for multiple variables, if we are to check the limit of several variables of the function of several variables, we'll have that we'll have that this for a single variable. So if we say we should check the limit of a function f of x comma y, that's this multiple variable where x comma y is approaching a comma b. If we check it and we check from the a direction, now we are approaching from a. Let's say we are approaching from a. Approaching a, and we get L1. And now we will check again the limit of several variables, let's say x and y, as x and y approaches what? A comma b from the b direction, let's say approaching b, is equals to what? L2, right? Now we are moving from the a direction for several variables, and we got L1. We are approaching the limit from the b direction, and we got L2. We can now say that if L1 is not equals to L2, the limit of several variables what? Does not exist. But we cannot say L1 equals to L2 will exist. We cannot say this when it comes to functions of several variables, because they have so many parts we can get to this what they call function. If we approach from A and approach from B and we get the same answer, we cannot just say it exists. Even though we have like 5 different parts getting the same answer, we cannot also say it exists. If we have 10, we cannot say it exists because there are multiple parts, almost infinite parts that you can use to approach from several variables. But it's more than one dimension, you know. So, but there are parts we can consider. Let's say we have 5 parts. To what? Consider if the limit exists in several variables. So the first part, if you are approaching from the what? X-axis. If you are approaching from the what? Y-axis. When x is equals to y, when x is equals to y, that means y is also equals to x, right? When x is equals to y squared, which is going to give us a parabolic graph, and when y is equals to what? X squared. So when we've checked approaching from x, approaching from y, approaching from x equals to y, approaching from x equals to y square and y equals to x square. And all the parts are giving us the same answer. Then we can consider and say it exists. But if four of them don't give us the same answer, like four of them give us the same answer, one is not giving us the same answer, it does not still exist. We can even say if the five of them itself, we can say it doesn't exist because it has multiple parts. So if you just take five, the ratio is not going to work. So now let's take some examples on limit of what? Several variables. Then after that, we'll look at how to convert limit of several variables to limit of a single what? Variable. So let's proceed. Let's take some examples so you understand. Let me look for some examples. So let's take an example. If we're asked to evaluate if we're asked to evaluate lim s cube minus y square over 2x square plus y. If we're asked to evaluate this, where x is approaching 0 and y is approaching 1. This is our first example. Let's write another example. This is example 1. Example 2, let's look at, it says you evaluate lim eight s square y minus 3 what? S cube plus what? 5 x y raised to the power 4 z, where x is approaching 1, y is approaching 2, and z is approaching minus 1. So let's look at these two examples on limits of a function of several variables. So let's look at these two examples. Are you following or you're lost? Are you following or you're lost? Hmm? Okay, maybe when we solve this example, you come back. Don't be lost too, please. Let's follow, let's follow. So the first example, solution. Solution. We are given a limit of x cubed minus y square all over what? 2x square plus y when x is approaching 0 and y is approaching 1. So the first thing we are going to do, look up. Please look up. The first thing we have to do is to use what? Substitution method. Substitution what? Method. We will substitute, since it's several variables, we work with the first variable, which is x, then we work with the next variable, which is y. If it was to be just one variable, we'll just substitute into the what? Equation to get it. I'm supposed to start with one variable, but I decided to start with two variables. Or should I carry it back so I should continue? Okay, proceed. So now doing this, we'll now have that anywhere we see x, what? Substitute, right? So our new equation will be what? 0 what? Cube minus what? Y square, right? Over what? 2 times what? 0 what? Square plus what? Y. So 0 cube will give us what? 0 minus what? Y square, correct. All over 2 times 0 square. 0 square will be what? 0. 0 times 2 will be what? 0 plus what? Y. So now we'll be left with what? Minus what? Y square, because 0 will go off, over what? Y. And if we cancel out y here and y here, we'll be left with what? Minus what? Y. So now, y is approaching what? 1. So now we'll substitute the value of y into what? Minus y to get our what? Limit, right? So now substituting, let me clean this other part of the board. So substituting, so now we'll substitute y into 1. We'll now have that what? Our answer for lim what? X cube minus y square over what? 2x square plus what? Y, as x is approaching 0 and y approaching 1, as equals to what? Minus what? 1. Because here we put what? We are putting what? Y now as 1 here. I see it. So the answer will now be what? Minus 1. So it will now be what? minus what? 1. So this is our limit now for this function, minus 1. So now let's look at the second example. Now this time we are given 3 variables, x, y, and what? Z. So let's bring it out. Lim eight what? X square y minus 3 what? S cube plus what? 5xy what? Z. All right. Where x is what? Approaching what? 1. Y is approaching what? 2. And z is approaching what? Minus 1. So the same thing. We'll substitute and simplify until we get our what? Final what? Answer. So let's do that. Now, when we did this simplification, we had minus y here, and we say y is approaching 1, right? We put in 1 anywhere we see y, so it will not be what? Minus what? 1, right? So I just simply what? I rewrote the what? Function. And then, since our final answer is 1, instead of what to waste space, I just wrote minus 1 at once. Are you seeing it? So that's how we got it. Yeah, you can also write substitute. You just put it here. That be what? Minus what? Y. So let's proceed. I was about cleaning the board. So now for this, we'll substitute x as equals to what? 1. So we'll have what? 8 into what? 1 square y minus what? 3 into what? 1 cube, right? 1 cube. 8 into 1 square y minus 3 into 1 cube minus 5 into 1. Okay, sorry, plus 5 into 1. Y raised to power 4 times what? Z. So if we simplify, we have that what? 8. 1 square will be what? 1, right? So let's write 8 times 1 is what? 8y minus 1 cube will be what? 1, right? 3 times 1 will be what? Minus 3 times 1 will be what? Minus 3. That's why we have minus 3. Plus what? 5 times 1 will be what? 5. 5 what? Y4z. Now we'll put what? We'll also substitute now. Put y equals to what? 2, right? So we'll put y as equals to 2. We'll have that what? 8 times y, that's 8 times 2, right? Minus 3 plus 5 times y raised to power 4, which is 5 times 2 raised to power 4 times what? Z. So simplifying, we have that 8 times 2 is what? 16 minus 3 plus what? 4 raised to power 4 is what? 4 times 4, sorry. 2 raised to the power 4 is what? 2 times 2 times 2 times 2. That's what? 16, right? So 16 times 5 is what? 80, right? 80 what? Z. So now 13 minus 3 will be what? 16 minus 3 is what? 13. Plus what? 80Z. Now we'll put what? Z as equals to what? Minus 1. Let me write it here so you see it. Minus 1. So put Z as what? Minus 1. We'll have that what? 13 plus 80Z. That's 80 times minus 1 is what? Minus 80, right? So our sign will change to what? Minus what? 80. And 13 minus 80 is what? Minus what? 60 what? 7. So we have that this limit will be equal to what? Minus what? 60 what? 7.